Okay, welcome to another day of Intro to Game Programming. We're at Lecture 3, introducing C# for Unity. So, programming in Unity. Today we're going to be talking mostly about C#, but a little bit about how C# and Unity interact with one another. And with regards to C#, obviously there's a lot to the C# programming language. We're not going to cover it all, certainly not even covering it all today, but we're going to focus on some basic features, the syntax, basic syntax, variables and structures, logic, loops, and conditionals. So let's see. Whoops. All right, we'll keep the right view here. So just to remind you that in Unity, we're dealing largely with the following objects, our game objects, our components, fields and properties, functions, and events. The C# that we're going to write is going to largely be focused around this part here, the components. Those are containers that group related functions and properties and are used on game objects. Okay, so they are comprised of these fields and properties and functions or methods, and they're going to make up these components. So just a reminder. Now, if you'll remember, in the last lecture we talked about, calling a function. This is the basic piece, calling a function. Unity has a built-in function called print, which allows you to print things to the console. So every programming language we see, that generally there is a print, sort of a hello world that we use to kind of print to the console. But for games, we're not going to really use print much, but we can use it sort of as a prototype to just sort of understand the basic syntax of a program statement. Okay, normally there'll be a function that gets called, and there will be some sort of argument that gets passed to that function. So in this case, the function is print, and the argument that is being passed, or the variables that are being passed, in this case just a single variable, hello world, a string that is hello world. And the parentheses are what separate the program, or excuse me, they separate the function from the argument and contain the argument or arguments. And the semicolon is at the end of the line that tells the compiler, yes, we are finished with a particular line. Now, like I mentioned, we're not going to be able to cover everything in C#. That would be far too much to cover, and then also cover game programming as well. So I'm going to give you a couple of resources here that you can refer to. Now, Unity 3D, they have their own Learning C# in Unity for beginners if you want to follow the path down there into some other interesting things. And Microsoft also has a number of C# tutorials, including an intro to C#, hello world. And we'll just jump over there for a second. So you can see, okay, coding in C# in Unity for beginners, and this is a really good resource. And we'll just leave that there. And the other interesting thing, this Microsoft resource, the cool thing about this one is there's an interactive C# tutorial here, and you can actually even go into this focused mode and interactively check your C#. So you can do things like, say, print hello world, and that becomes our function here. We can say, okay, run our function. Oh, print does not exist in the current context. All right, we want to do console write line. Okay. And what that demonstrates is that something like print is really a shortcut to something else in a lot of cases. Like here, we're writing to the console, and inside of Unity, we're actually using debug.print. That's what's being used for that print that we use in Unity, this piece here, believe it or not. So even this print is not directly print. It is a debug.log. Okay? All right, so those are some resources for you to check out if you want to go above and beyond where we are today, or if you want to go into more depth and detail on things. So one of the questions, first off, what's the difference? What is different about using C# inside of Unity versus just using C# on its own? And one of the things you're going to notice that you're going to be writing components, not programs. In C#, if you were just writing C# on its own, you would probably have a class that would contain a main. Now, if you're coming from this from another programming language, you may very well have seen a main program, and that's the thing that gets run every time. But instead, we're going to be writing components for the most part. And components are things that are going to be living on game objects. So we're not defining the entry point for our program like we would in a typical program that we would write from scratch. So that's the big difference in using Unity here. That there is a lot of stuff that's taken care of for us outside, and instead we're just putting our components on these objects, right? But components are classes, just like the program is a class. Components are self-contained classes. They inherit from mono behaviors, which we're going to become familiar with, and because they inherit from mono behaviors, these components have certain methods that are automatically called at the right time for us. Okay, so just like main is called as soon as the program runs, when you have a standalone C# application or a standalone C# program, we're going to have these things that sort of automatically happen for us. The ones we'll first notice are start, update, but there are many more as well. Okay, so you'll notice like in here, your components, by default, it's going to put a start and an update routine method in there for your class. Now, another thing to remember, keep in mind, compiler errors in components will prevent your game from running. Okay, so even though you're going to be potentially popping back and forth between Visual Studio and Unity, if you have compiler errors in components, be careful. Always pay attention to what's going on inside the console window, because it will tell you if you have compiler errors. You'll see that. And if you have compiler errors, it may very well kind of gum up your entire game. Right? You can't just leave a programming error in a script inside of your project, because that will prevent a lot of things from potentially happening. Right? So you want well-formed code, hopefully at all times. Don't leave half-written code in your libraries. That's going to be potentially problematic. Now, that said, even though we're saying, yeah, we're going to use components almost all the time, just like Drake was indicating, there are uses for C# in Unity as well. Okay, you can write libraries, and there's a more advanced model now called the entity component system, where you can write these individual things called entities, components, and systems. We're not going to get into the ECS. That's a rather complex paradigm that allows for more performant code writing, but it is a little bit more. You want to definitely cover the basics first of component writing. We probably will look at libraries and how to create some libraries of our own, so that we can then do things like derive classes and use inheritance and things like that. So we may very well have some time to look at libraries. But for the most part, we're going to be working with components. Okay. Now, let's start with the basics, though. So those of you coming from other languages, this is going to be some important syntax, some important differences between this C# and other languages. Now, some of them may be actually quite similar. I like to cover this first, because documenting your code, commenting your code cannot be emphasized enough. I see it consistently that people tend to leave comments out. They tend to leave them for last if they do add them. But for your own sake, for my sake also, I'm going to insist that you do comment your code. There's a number of different commenting styles that you can use. I do want to see you put, author, put yourself as the author, and note that in your classes as well. So imagine, you were doing this project as part of a larger group. People would want to know, okay, who wrote what code, what happened in it, what changed it, what's the purpose of this particular function or this particular class, and so on. So we're going to use that to get this across, right? The comments are for yourself, and as well as other programmers as well. In the end, comments are just compiled away. The engine doesn't really care about them, but they are important for maintenance and for clarification on a lot of different things. So, similar to a lot of other languages, we have the double slash, the double forward slash, which indicates a single line comment, just like this. If you just wanted to put a quick comment that is on a single line, you can do that. Or you can use this slash asterisk, which will indicate a block comment. So everything is ignored until the comment is closed. So we have an open and a close comment. All right. Now, there's this other extra one, which we probably won't use much, but you should be aware of it just in case you're looking at anyone else's code, that there is the triple slash. And this allows you to use automatic or to create automatic documentation using XML tags. So you can use triple slash and then begin summary, and then later on, put a bunch of code in here, and then say, or a bunch of comments in here, triple slash end summary. Okay, so this would allow you to do things like creating automatic documentation. That's again going to be more important if you're working on as part of a larger team or a larger project. So we're probably not going to see a lot of the summary comments in here, but you may run into some of them. Okay. All right. So, other basics: parentheses, braces, angle brackets. You're going to see those a lot, and you may have certain opinions on them from other programming languages, so we'll just kind of cover them here just in case. All right. Braces, or curly braces, that's when you're creating structure, you're defining blocks of code, or what is within a method or function. Okay. So if you have a class which has some sort of structure to it, some block of code, some scope, that's going to be used as well. So these curly braces, the braces are to establish scope and blocks of things, okay? So methods, classes, structures, and so on. They're all contained within braces, right? Parentheses, the normal parentheses, they're used when you're calling functions and specifically when you're passing values to a function or a method, right? So when you are calling a method or a function, we're going to use parentheses for that. Square brackets are used when you're accessing an element within a collection. So for example, if you're using an array or a list, you're going to look at the individual elements within a collection using that. So you could say the 0th element, the 12th element, and so on, the 5th element. And last but not least are the angle brackets. Okay, angle brackets you may have not seen before in some of your other programming classes, and this is important in object-oriented programming and specifically in C# for passing a type to a generic function. Okay, so there may be functions that are going to rely on a type in order to be executed, right? So as you get components or other different sorts of things in Unity, and you have to pass the type that you're interested in to the generic version of the function, you're going to use that to tell it what the type, right? So whenever you're passing a type to a function, you wind up using this. So sometimes you will see like the angle brackets used in conjunction with the parentheses. So if you're finding a generic function, you want to say what type it is and then call the function using the parentheses. So you will see these used in combination with each other. Okay. Naming conventions. You do have lots of options when it comes to naming conventions. This is sort of what I expect to see in the class and in your code. As you get into other things and beyond this, you may feel free to then ignore them. But for now, to make it easier for us to all understand one another, I'm going to ask that you use what's called camel case or Pascal case. There's a couple of different names for it, but the idea is basically it's called camel case because there are sort of these humps in the middle of the words that establish when one word ends and another word begins. Right? So we want to use these multiple words in names to make things clear as to what they are. And normally you're going to capitalize each new word in the name. But the first letter, like in this case the C, the first letter is special. Okay. And generally what we're going to do is say that functions and Unity or user-defined classes, they should start with an uppercase letter. Okay. Functions, methods, classes should start with an uppercase letter like this. This is a function. And these are Unity's built-in and also potentially user-defined classes. You see they start with a G, capital R, right? So when you're creating your functions that are your C# scripts that are ultimately your classes, you should always name your C# scripts starting with a capital, right? So that they comply with this rigid body, game object, and so on. Variables and built-ins will start with lowercase letters. So this is how we establish. We might have a lowercase game object. That would mean that that is a variable. It is an instance of an actual type or a class called game object. So we'll be able to tell the difference between variables and classes that way. But the built-in types, int, float, public, and private, are all going to be lowercase like that. So within that, we're going to say almost all of our coding will occur within the scope of a class. That's almost always. And usually, code is being called as part of an event. Okay, so let's look here in our first case. As we get into Unity, if we establish, we write a script, it's going to create this mono behavior for us. And this would be the master class, which has a, well, this particular slide has a lowercase m, which it shouldn't. That should be a capital M. And then you'll see it has its start method and its update method here. Okay. And those are called automatically for us by Unity. Right? Start is going to happen when this program, when the game starts, and update is going to get called over and over and over again every time a frame is drawn on the screen. Okay, so all of our code is usually going to be within this context here, usually as some sort of event, like a frame being drawn or the start of the game. Right? That's the idea of the events there. So functions are there. Functions and methods are there to manipulate and ultimately controlled by data as variables. Okay, so that's how they are interacting with things called variables. So variables are declared with a type. C# is usually considered a strongly typed language. So this might be different from some of the other languages that you're used to using, right? Whenever we have a variable, we want to say what the type of that variable is. Okay, there are some ways around that, which we'll get into as we get into sometimes when we're using inheritance, and you might not know exactly what type something is. There are some shortcuts that allow you to sort of violate this rule a little bit when you are when you want to use something that may have been inherited from some sort of base class. But generally, we want to consider and work in a strongly typed manner, right? So int is going to be our integers, right? Our whole numbers here. Float are decimal numbers. Note we want to use floats, not double precision. So we're always going to be using the f, so 0.0f. If you leave out the f, it would consider that to be not a floating point. It might use a double precision or some other type of decimal number. We're going to use floats here. That's what Unity likes. Bool for booleans, which are just true or false, right? They are on or off, true or false. They are used for logic. And then we have strings, of course, sequences of text characters such as hello, which has some, it's not just a sequence of characters, but it has some other, functionality and things kind of built into it. But these are one of the basic types you're going to be using here. Now, classes are collections of rules of data that are compound types. Right? So for example, there are some built-in ones that you'll be using, like vector2, which is going to have an x and a y component. Right, so it's going to have those two bits of data included in them, as well as certain types of ways of interacting with them. And vector3s, and then also the more complex ones, such as game objects and rigid bodies, and so on. All right. So in your code, when you want to declare a variable, this is the syntax of it. Right, you say what type the variable is going to be. You give it a name. You have an assignment operator. You have a value and then an end, right? So int health points equals 5. That's one of the kind of single line way to create a variable and initialize it, right? Or you could just initialize it to some unknown state, just declare it here, int health points, and then set it, specifically health points equals 5, right? So then you could set a value for it after just sort of declaring it, right? Within C# there's also this notion of scope. Okay, and we discussed this in passing just a little bit. The idea that variables, since everything lives within a class, we can establish whether something is public in scope or private in scope. And there's another scope called protected, which we'll talk about when we get into the context of inheritance. But for now, let's just talk about public and private. So when you have something that's inside a class that you do not want any other classes or any other code to get at, you kind of you will normally see it just as if you don't declare it to be anything, it will be private by default. But sometimes you might want to specifically say private. So in this case, like private float foof. Okay, that means this is private and it is not accessible by any code outside of this class. Okay, that's assumed by default. Public is accessible from anywhere in this script or potentially in other scripts that know about this class. Okay, so you could say public int foo, and then that would be accessible from other programs if they or other classes if they wanted to modify it in this class or in an instance of this class. This one here, int bar equals 20, that is assumed to be private. So that would be something that would not be accessible from other classes. One really interesting application of public fields is that they are available to the Unity editor. So your scripts can be modified, or to some degree they can be modified, at least the initializers, by the Unity editor itself. Okay, so for example here, if we had a class that had these a set of strings or a set of ints or a set of bools and so on, they would be accessible here. Let's actually do this as an example. Okay, so if I come over to Unity and I've got my project here, and I will go to my empty scene. Okay, and here there's a canvas, there is the main camera, but there's really kind of nothing going on. So I will create an empty object in my scene, and it's at the center of the world at 0, 0, 0. Just move it around just to be somewhere. And maybe I make this the game manager. So there's going to be some sort of code in this on this object here that is going to run the game for me, right? Game manager. Okay, whoops. Game manager. All right, so that's the game manager object. And I'm going to add a component to it called, let's see, game manager. Create and add. And you'll see it will create a script for me. And let's see, where did it put that script? Probably put it right in the assets folder by default. You'll see game manager, and it gives me this gear. And the gear really is just there for show. Unity likes to create, if you create a script, a component called a game manager, it will put this gear on it, just so you know about that. Okay, so I'm going to drag that into my scripts folder. And while I'm here, I'm also going to grab my seal component or seal controller, and I'll put that in my scripts folder. I like to keep things organized into various folders like this. Let's see. So it's good to get into a habit. So we have one for images, one for scenes, one for scripts, one for sounds. All right. So in scripts here, and I have my game manager. And let's double click on there. Now I can see the code that is part of my the code that makes up my game manager, and it's there in the scene. So I have a start function and an update function. I'm going to get rid of update for now. Okay, update is really going to become more important in the second project. You really shouldn't be using update in the first project because it's going to be a turn-based game. It doesn't really have graphics on the screen. Okay, so in our start, we're going to have, well, nothing yet. Up here, the goal here was to really just to put a public variable. So say I had int number of lives, okay? Because the game manager is going to keep track of the number of lives that the player has. And by default, we're going to start off with 3 lives. So I've declared an integer called number of lives equals 3. Now maybe in start here, I'm going to say print number of lives is, and this is just for debugging purposes. And I can concatenate that with number of lives. And I use tab and just auto completes here. Okay, so when the program starts, when the game starts, it's going to call this start function, and we will see it print out number of lives. Okay, save that over here. And if all goes well, and I hit play, number of lives is 3. Okay, so that's all that's going on in the scene. That got called because the game started. That's what happened right there. And all right, save that again. Now you'll notice over here on the game manager object, the game manager script just has the script name. I can't change the number of lives there. So if I wanted to be able to change that from the Unity editor, I would have to come over here and declare this to be public. Okay, so now once it is public and it's saved, I come back to Unity and it does its auto update. You'll see now number of lives 3, and that will be set up automatically. And I can change it here. Okay, so if I change something here, say I change this to 5, it's going to modify it in the code automatically. It's going to go basically into the code and say, all right, this 3 here is now a 5. So if I clear out the console and press play, you'll see number of lives is 5. Okay, now once I've modified something here, it is always going to be modified. So let's see if I delete that. You see now it's 0. Number of lives is 0. Okay. Once you touch something here, it is sort of touched forever. The only way to sort of get rid of it is you'd have to go back into Game Manager and say you cut that and got rid of it here. So then, oh, well, it's not compiled, so it didn't actually change it in there. And we'll put it back. Save it. Let's see if it's, nope, didn't bring it back yet. So it's kind of tricky to get it back after you've modified it. So be careful. Once you modify it here, make sure you kind of keep the two in sync with one another. So this is one of these cases where you can wind up having the Unity editor and your C# compiler here sort of fight one another a little bit. Okay, so but we've declared a public. That was the main purpose here. Let's jump back over to our presentation. All right, get back to this. And interesting. It is not giving me the presenter view again. The presenter view. All right, we're back. There are some other things you can decorate those publics with if you want to show them as sliders or you want to show tooltips and so on inside the Unity editor. You can decorate them according to that. We'll get into that a little bit later as well. All right. So now let's take a quick tour of C# operators. By operators, they're basically the built-in functions that are symbolically represented. Okay, so for example, the simplest we have is assignment. So we could say, this variable x is being operated on, and it is having 50.05 float, this number, assigned to it. So equals is the simplest operator. It's just assignment. Then we have a set of arithmetic operators, which are used to perform operations such as addition, subtraction, multiplication, division, and so on. Okay, this is going to be very, very similar to what you've probably seen in other programming languages. Okay, so the ones you may not have seen, or maybe you haven't really used, things like modulo, where you can figure out the remainder of something. So like, for example, 16 modulo 3, the remainder of 16 divided by 3. So 16 divided by 3 is going to give you 15 with a remainder of 1. Okay, since we're looking at integers here, right? And even integer division, 10 divided by 5 equals to 2, and so on. All right, so I'll leave that there. You can refer back to this lecture, these lecture notes, largely as sort of your reference for C#, if you need one. All right. Then relational operators are going to be largely your logical operators. They're going to be evaluated to true or false. So these are going to wind up generating a Boolean value. So, for example, the equals operator, and you're going to be careful. This is not assignment, so you can't, if you want to compare two numbers, you don't use the assignment, which is the single equals. You're going to want to use the double equals, which is your comparison. Okay, and it's comparing to see if two things are equal. So if you said, for example, 6 equals 4, that would evaluate to false. Right? 6 is certainly not equal 4. Right? Relational operators such as this, largely used for decision making and for loops. So, for example, if you want to loop over something a certain number of times until something increments past a certain value or decrements beneath a certain value, that's what we're going to use these for here. Okay. Then there are logical operators. So when you want to combine a number of logical conditions and evaluate them as a group, you're going to use a logical operator such as and, or, and so on. Right? Usually and or are the main logical operators you're going to be working with. So for example, if two things, if you or, just think about this logically, pardon the pun, if operator 1 or operand 1 is true, operand 2 is true, if you said, okay, is operand 1 or operand 2 true, that's true. Is operand 1 true and operand 2 true? Yes, they're both true. Right? So if either of them were false, one or the other, you can see, oh, this or that, right? If one of them, if at least one of them is true, then or is true. But and is false, right? So you can't say true and false, that's false, right? Only true and true is true. But then we get into the last case where with both operands are false. False or false is false, and false and false is also false. Okay, so these are hopefully pretty straightforward. They're going to be very, very useful. Another type of operator, unary operators. Unary operators they operate basically on a single operand. Sometimes you'll see them used in a context where they're then part of an assignment, but they operate on a single operand, right? So C++, for example, is a classic unary plus, right? Unary increment, right? So this will take the variable C and increment it. C minus minus will take this variable C and decrement it. Basically, subtract 1 from it and assign it. Okay. Unary plus really doesn't do much of anything. Unary minus will invert the sign of an operand, right? So if you said minus C and C happened to be positive, it would then become negative, right? Then you also have logical negation, which will negate. So if something was true, it'll make it false. If something was false, it would make it true. All right. And then there's the rare ternary operator, and this is really just used for showing off or to save a line of code here and there. If you don't want to use an if statement, you can use the ternary operator, which is this question mark colon, to operate on 3 operands, or almost a three-part statement. Okay, ternary operator is used as this when you have a variable that is assigned to something, to one expression or another expression based on a condition. So if this condition is true, the expression 1 is used. If this condition is false, then this one is used. So it's sort of like an if-else, right? Or an if-then kind of, or if-else, really. Yeah, if-else. And we'll cover conditionals more later, right? So just to be aware of that, if you see this kind of structure here, that's what you're dealing with. There's also bitwise and bitshift operators. You're going to be working with those much later on as we start looking at something called masks, where we need to manipulate individual bits of certain variables, where you want to say, okay, this particular bit changes according to some condition, or maybe you have a group of layers that you need to figure out, okay, this thing only interacts with a certain layer out of a group of layers. So you might wind up using these bitwise operators to manipulate or check or test individual bits within a field. Okay, so be aware of these. The complement and or, you'll notice they have their own and and or here. These are not the logical ones. The logical ones, we had and or are the double bar and double ampersand, right? Just like the logical or the relational operator here for equals, which evaluates to true or false, is the double equals, right? So usually a logical comparison is the double uh, version of the and or. The one that gets a little bit odd is when you're doing bitwise manipulation, you use the double less than or double greater than to do bit shifting, bitwise left shifting and bitwise right shifting. That'll make much more sense later in the course. We'll come back to that one. Okay. Then there are ways of doing things like combining operators using plus equals, minus equals, and so on. So this way, if you want to operate on a single operand, you can often use these compound assignments to do just that. Right? So if you want to just quickly add 5 to x, you can say x plus equals 5, which is equivalent to x equals x plus 5. Right? And that goes similarly for just about all of the other operands you can use in similar ways. Right? So, take a deep breath. Mentioned that C#, we like it to be we like to consider it a strongly typed language. We like to make sure of the type of our variables as we use them. And sometimes that means you're going to need to convert from different types to other types. So you want to convert one value to another value. So for example, we want to convert a string to an int, or convert an int to a string or a bool, and so on and so on. These are some examples of that, right? One way, if you want to convert a number to a string, which I demonstrated before, where I wanted to have that hit points, the number of lives, I just went ahead and concatenated it with that string, with another string, and that converted this automatically. Or I could also explicitly convert an integer to a string by just saying dot to string. Okay, so most variable types have ways of converting them to string. Then you can also do things like parse strings and convert them to other types as well. So bool.parse, you can parse this string to see does that evaluate to true, right? So types do have methods within them to do things like converting values. Whew. Bunch of stuff. Now we're finally going to get into a little bit of structure, and this should be fairly similar to, I don't know why this got converted a little bit odd here as I went through. The single most common conditional that you'll probably deal with is the good old if-else function. There specifically isn't a then in C# or most of the C programming languages. We just assume the then part if we want to have a then clause. So if-else, the goal is to look, okay, if you want to perform one action if true, another if false. So for example, in here, we want to say, night is false, and if it's night, you shouldn't be concerned about anything. Werewolves don't come out at night. But you might say, if night, print it's night. Else, print what are you worried about? Or you could say, okay, print it's not night, right? So the output of this code is simply, what are you worried about? If we jumped back over to our Unity again, we'll do that. And we'll go to our game manager and look at our game manager code. We could certainly say something like this. We could say if number of lives equals 0, let's do one thing, else print number of lives. So maybe here we want to say print you died. Okay, now normally that wouldn't happen at the start of the program. That would be an odd thing to happen. But we're just going to use this as an example. So if this is set to 0, and it's probably not going to work, or it's probably not going to do what I think it's going to do, because you'll see up in here, oh wait, it's set to 3, right? And that is because here in Game Manager that was set to 3. All right, so we'll set this to 0, and we'll clear that and run. You died. Okay, and that's because our code, and we'll click here, you can see it right here, if number of lives equal to 0, this is the code that gets run. Else, this is the code that gets run. You've probably seen this before, but in case you haven't, that is the basics of that. All right. All right. Now, fields versus properties. This is something else that is emphasized in C# etiquette, so that you can leave fields private and use properties as a means to access the data within there. This is going to also become a little bit more relevant in more complex classes. So for now, just be aware. Sometimes you will see, or you hear this terminology, getters and setters, and that's what is going on here. Because a lot of the time, you don't necessarily want someone changing some sort of internal thing here. Part of object-oriented programming is that you don't want any unnecessary access to the components, to the pieces, sorry, not components, to the parts of a object by other classes, other objects. You want to hide the data in there as much as possible so that they don't do odd things to it. You want to protect the data inside there. And normally you want to do things like, instead of declaring the value itself to be public, you can declare the value here, the actual data, whoops, the data to be private, and set up these getters and setters that would allow you to change the values. But we won't to get too much into that right now. All right. So this is normally where we'd stop. So I'm going to, well, it's not where we normally stop. I'm going to divide this into 2 parts. So I'm going to stop this lecture now, if you want a bit of a pause and relax, and we'll come back to this in the next installment.